Kingside.com. Kingside.com.
Howdy, howdy, howdy. Welcome to the lesson on inheritance. According to dictionary.com, in object-oriented programming, the ability to derive new classes from existing classes. A subclass inherits the variables and methods of the superclass and may/should add new variables and methods. Remember, in PHP, sometimes we call the variables properties. So you might read this as a subclass inherits the properties and methods of a superclass and may or should add new properties and methods. A practical definition or a practical way of looking at inheritance is never start with an empty editor window and type in all the code yourself. Find an existing class that does most of what you want and build on top of it. Is there a class that has 80% of the variables and methods you need? Build on top of that, and you only have to write 20% of code. That is code reuse. Here's a non-computer example of using inheritance. Let's say we want to build a tow truck. Now you can go out and buy the individual parts, an engine, a transmission, a chassis, a tow harness, all the pieces needed, put them together piece by piece. Or if you want to create a tow truck, go out and buy a Ford F-350 pickup truck, which is 95% of what you need. Remove the bed of that pickup, bolt on a tow harness, and bam! You got a tow truck. It's much easier to build a tow truck out of an existing pickup truck than to try and create one piece by piece. That's the idea behind inheritance. When I'm ready to write a class, if I can find one that's close, I build on top of it and I only have to write the difference. Part of the difficulty of learning inheritance is learning the terms associated with it. There are several early books on inheritance that kind of describe the same thing using different words. So the key to understanding inheritance is to understand the terms used to describe inheritance. The keyword extends says we want to create a new class out of an existing class. When we write class vampire extends enemy, vampire is the new class and enemy is the existing class that we're building on top of. The following terms are used to describe these two classes: superclass or subclass. Enemy would be the superclass and vampire would be the subclass. Parent class and child class. Enemy would be the parent class, zombie would be the child class. Base class and derived class. Enemy would be the base class, derived would be the mutant. Each term on the left is an existing class, and the term on the right is the new class that you're building out of it. In this first example, class vampire is the new class that we're creating by extending the existing class enemy. Vampire would inherit the variables and methods of enemy, or the properties and methods of enemy. Vampire in this case is known as the subclass, and enemy is known as the superclass. PHP and Java languages refer using the term superclass or subclass when describing this inheritance relationship. In fact, the PHP documentation sometimes uses the term superclass and subclass. Sometimes it uses parent and child. PHP is very open to what terms it's used to describe. Java is very clear. It always calls them the super and the subclass. PHP is a little more mixed up, as we'll see in a little bit. But it's certainly a set of terms you need to understand: superclass and subclass. Vampire is a subclass, enemy is a superclass. In the next example, class zombie is the new class that is created by extending the existing class enemy. Zombie then inherits the properties and methods of enemy. Zombie would be known as the child class, and enemy is known as the parent class. I prefer using the terms parent and child class because they match the term inheritance. We understand inheritance. A child inherits eye color or hair color from a parent. The child always gets things from the parents when we're talking about human inheritance. The child class zombie inherits the properties and variables of the parent class enemy. In this example, class mutant is the new class that is created by extending the class enemy. Mutant inherits the variables and methods of enemy, sometimes called the properties and methods of enemy. Mutant is known as the derived class, and enemy is known as the base class in this situation. Now, some books use the terms base and derived class. The word derived means it was created from something else. The word base means something that you build on. Mutant is derived from or based on the class enemy. Which set of terms you use is up to you. Sometimes it's language specific. Java is very into superclass and subclass. PHP uses parent class and child class a lot, as well as superclass and subclass. It really depends on what you're reading, what language you're using, which set of terms you use. Having three sets of terms to describe the new and existing class when doing inheritance is not ideal. Different programming languages, textbooks, or online documentation use different terms, and we have to live with it. The only thing I ask is don't mix and match the terms. Never say the subclass was created from the parent class or the derived class was created from the superclass. If you're going to use subclass, call the existing class the superclass. If you're going to use child class to describe the new class, definitely use parent to describe the existing class. Do not mix and match the terms. Here's the meat of an inheritance. This is what you really need to understand when you build an object from a subclass vampire. It's going to have all the variables and methods from vampire plus all the variables and methods from the superclass enemy. And again, keep in mind, sometimes we call the variables properties to indicate they are part of an object. Look at this line of code. Vamp object equals new vampire. When I build this object and assign it to the reference vamp object, look what's inside that object. Of course, a vampire object will have vampires, variables, and vampire methods. Duh. But vampire extends enemy and therefore inherits everything enemy has. As extending enemy, it's going to have enemy variables and enemy methods. That's the important part to understand about inheritance. When you build the new class, it will have variables and methods from both its class and its superclass. Just to reinforce that, let's look at a zombie object and build a new zombie object out of class zombie. Just like a child may inherit blonde hair from their mother and blue eyes from their father, the child class zombie inherits the variables and methods from the parent class enemy. Looking closely at this zombie object that is created by this line of code underscored in red, of course a zombie object will have zombie variables and zombie methods. It's a zombie. But zombie extends enemy, so it will also have all of enemy variables and all of enemy methods. Enemy has declared an X position, Y position, then this zombie object will have an X position, Y position. Everything that the class enemy has, a zombie object will have. Now look at the line of red. Mut object equals new mutant. When the derived class mutant extends the base class enemy, it starts with all the enemy's variables and methods. It then adds its own variables and methods. The resulting object has both sets of variables and methods. And if we follow the red arrow over to the mut object, of course the mutant object will have mutant variables and mutant methods. Duh, it's a mutant. But it will also have enemy variables and enemy methods. When you extend a base class, you inherit all the variables and methods of that base class. In object-oriented programming, or OOP, the ability to derive new classes from existing classes. A subclass inherits the variables and methods of the superclass and may/should add new variables and methods. This is code reuse. We want to write the code once in a class enemy and use it when building vampire, zombie, and mutant. Remember, sometimes many books refer to the variables as properties. So you may read this as the subclass inherits the properties and methods of a superclass and should add its new properties and methods. Property is just an object-oriented term that describes a variable that is part of an object. Parent and child class design. The key to understanding and programming using inheritance is to understand what goes in the parent class and what goes in the child class. So let's do a slide describing what goes in the parent class and child class. This is what we call an inheritance diagram. It shows the child classes soldier, drone, tiger all inherit from a common parent class called enemy. The class soldier would extend enemy, and you could see soldier picks up everything enemy has. Class drone extends enemy. This arrow says drone is going to get everything that enemy has. Class tiger extends enemy. This arrow indicates tiger will get everything enemy has. What variables and methods should go in class enemy? What variables and methods should go in classes soldier, drone, and tiger? Good design leads to better code reuse, and understanding the relationship between the parent and child class and what should go in each is key to object-oriented programming using inheritance. The parent class enemy. Common or shared elements belong in the parent class enemy. What properties and methods do all enemies share? What variables and methods do all enemies have in common? As far as the variables, all enemies need an X pos and a Y pos, an X position and a Y position, an X coordinate and a Y coordinate. They all need a health variable. Remember, these are enemies we're battling in a video game. We're firing at them, they're firing at us. The health variable is keeping track of how healthy they are. You get that health to 0, your enemy should die. Since they all need an X, Y, and health variable, declare them once in parent class enemy, and all the child classes, soldier, vampire, drone, etc., will have these properties. There's no reason to redeclare the variables in soldier, drone, and tiger if they all have them. Write them once in the class enemy. What about the methods? All enemy objects need to move. They need to attack. They need methods to do these things. Enemies move about the screen and launch attacks on the players. What functions and methods define what the object does? The things that all enemies have in common, you should put in the class enemy. When designing a parent class, put in the shared variables and methods of all child classes. To wrap it up, common elements. What do every enemy objects have in common? Those variables and those methods belong in the parent class enemy. What belongs in the child classes? Let's look at soldier specifically first. The unique are specific elements in the child class soldiers. What properties or methods does only a soldier need? Think about the variables. Only a soldier needs a rank and weapon variable. Is this soldier a private or sergeant? Do they have a handgun or do they have a rifle? Tigers and vampires and drones don't need a military rank. So if it's something specific to soldier, like this soldier's rank, put it in class soldier. What about methods? Only a soldier needs a reload method. Since a tiger can't change their claws and drones can't add new missiles in flight, a reload my gun method is unique to soldier. It belongs in the child class. When designing a child class, put the unique variables and methods for that child class in the child class. Only the soldier object needs a military rank. If you put it in class enemy, drone and tiger would inherit a military rank. So if it's unique or specific to soldier, put it in the child class soldier. Here's a drone. The drone is the only option in this that actually flies. So unique or specific elements belong in that child class. Drone. What variables and methods only a drone needs? Anything that has to do with flight. We don't have flying soldiers. We don't have flying tigers. Anything that has to do with flight belongs in the child class drone. Class drone extends enemy. What are we going to put in drone? As far as variables, it's flying. A drone is the only flying object that we have. Any property like height or altitude or airspeed that has to do with flight would go in the child class drone. What about methods? Only the drone needs a remote command method. Only the drone is controlled remotely. A drone has someone on the ground sending remote commands, like lower your altitude. It belongs in the child class. Common or shared elements belong in the parent. Unique or specific elements, like those doing with flight, belong in the child class drone. Let's look at Tiger now. Remember, Tiger inherits everything enemy has. Class Tiger extends enemy. What unique or specific elements belong in the child class Tiger? What properties or methods does only a tiger need? What about variables? An isKitten Boolean variable. When true, this is a baby tiger and it meows instead of roars. There's no such thing as a baby drone, but a baby tiger is the cutest thing ever. Declare the isKitten variable in the child class Tiger. What about methods? Only a tiger needs a slash and or a bite method. And with the isKitten variable, you can laugh when a baby tiger bites and die when an adult tiger bites. Anything has to do with slashing or biting belongs in the tiger class because it's unique to the tiger, especially compared to the drone or the soldier. A tiger behaves very different than a drone or a soldier. Put those things that are different in the tiger class. A class vampire and tiger both might have a bite method. In that case, you're a little, where does it go? Does it go in the parent or does it go in child? In this case, I'd put a unique copy in each child class. A tiger bite is very, very different than a vampire bite. So I would not put something like that in class enemy. A lot of times this boils down to how many classes does it apply for. If I was building 10 enemy objects and there was something that could be used in 8 of them, I might put it in the parent class. But if it was something that was only needed in 3 of the 10, I'd put unique copies in the child classes. As you can see, inheritance is most often used when designing multiple related classes. Therefore, you can write the common code once and share it with the child classes. This is an important idea. If I'm building 1 or 2 classes, do I really need inheritance? Maybe not. But if I'm building 5, 6, 7 classes and they're all similar to one another but with some uniqueness, that's when I want to use inheritance. Enemy is the parent class to things like vampire, mutant, soldier, tiger, anything that we're battling in the video game. That's when you start to use inheritance. I need 4, 5, 6, 7 different classes that are similar but have some uniqueness. We can apply this to many different design scenarios. What if you were doing a car racing game? You might build a car parent class and then have child classes like Ferrari, Corvette, Prius, Tesla. All these cars have lots of things in common. They all have an engine. They all have 4 wheels. They all have a steering wheel. Put all that common stuff in the class car and then put the unique stuff in the child class. Tesla is full electric, so anything that has to do with being a full electric car, you put in Tesla. Prius is a hybrid. Anything that has to do with a hybrid, you put it in the Prius class. Common elements would go in class car. Unique things like full electric go in the child class. What about shape? Shape is a parent class to child classes like circle, rectangle, triangle. When we're building the background of a video game, a background in a video game is built out of many small circles, rectangles, triangles, geometric shapes. You can build a parent class shape and put everything that all shapes have in common into the parent class shape. And then I could put unique things like radius in circle, width and height in rectangle, base and height in triangle. See what I mean? There's lots of different ways to use inheritance, especially when you start designing classes that have things in common. Here's a little formula here. Looks like a math equation, but it's more of an object-oriented equation. The more code you can put in the parent class, that equals faster development plus code reuse. There's 2 primary reasons for doing inheritance. Number 1, it should be faster, especially when you're building multiple classes that have something in common. If you can build a new class on top of an existing class, that's code you don't have to write. Faster development. It's also shared or common code. If I put the X position, Y position, and health variables in class enemy, I don't have to put them in soldier, drone, tiger, vampire, mutant, etc., etc., etc. More code in the parent class, you can write your code faster, and you're reusing code that you already wrote. You're not duplicating the same code over and over and over again. All in all, inheritance is a pretty good deal, and the better you get at it, the faster you can code. Drill down and get a little more detailed in how inheritance work. What we're going to do here on this line of code is build a soldier object. Sold object is short for soldier object. I'm going to build a new soldier object. Follow the arrow down from the red line to the object that gets built. Notice how the variables from soldier are in blue. I wrote soldier in blue, so I'll put its variables in blue. And the variables inherited from enemy are in red. Soldier might have a rank and a weapon variable. This object will have a rank and weapon variable. But inheriting from enemy, here in red, is an X position, Y position, and a health variable. The soldier object will end up having the variables from both the soldier class and the enemy class. Remember, an object is a combination of variables and methods from the parent and child when you're doing inheritance. Same thing for the methods. Look at the methods. Soldier needs a reload. They got to reload that gun. Soldier also needs a move and attack method. They'll inherit move and attack from the parent class enemy, add their reload method, and when you put both of these things together, the things from soldier and the things from enemy, you get a fully functioning class / object. Let's build a drone object. Drone obj is short for drone object equals a new drone object. Follow the red line and look at what goes inside this drone object. Notice how the drone object has its own variables and methods listed in blue. Drones need to keep track of an airspeed and their height. Drone needs to be able to take a remote control command. All of this stuff are from the drone class. And look what it gets from the parent class. Enemy variables and methods are listed in red. Drones have an X and Y position on the screen. Drones have a health. You're going to shoot this drone down. It's your enemy. You want it, when it goes to 0, to lose altitude and crash. Also in the methods, you'll get the remote command and you'll get the move and attack from the parent class enemy. When doing inheritance, the child class is a combination of variables and methods from that class and its parent's class. Let's build a tiger object. TIGR-OBJ is short for tiger object. We'll build a new tiger object and visualize what that tiger object looks like in computer memory. Note the enemy variables and methods in red. These things only have to be coded once in the parent class. I only have to declare X position, Y position, and health up here in class enemy. Once I do it once in enemy, it automatically gets picked up by all these child classes. That's code reuse. I'm using the same code over and over again in these 3 objects. Now what if I also built a vampire and a mutant and a zombie object out of enemy? That's 6 classes now that I only have to write this code once for. Inheritance is an important part of developing code and video games. You can build on top of what already exists. That leads to faster development and code reuse. To wrap it up, in the superclass, place all the common or shared variables and methods. Anything that all enemy objects have in common, put it in the class enemy. In the subclass, place all the unique or specific variables and methods. If it's unique to a drone, things that have to do with flight, put it in drone. If it's something that everybody has in common, like an X and Y position, put it in class enemy. Private, public, and protected. Now that we're using inheritance, we have a new access mode. Now we've talked about private and public before, but just to reinforce it and make sure that you understand it, we'll go over it again now that we're using inheritance and this new access mode called protected. Private, public, and protected are what we call access mode. What code has direct access to this element? It's not whether something exists or not exists. It exists. If you declare a variable, it exists. It's a question of who has access to that variable. Who can put a new value in the variable? Who can extract the value from the variable? Private means only this class has access to the element. If I declare something private in enemy, only enemy has access to it. Public means everybody. Every class has access to the element. If I declare something is public in class enemy, then enemy has access to it, tiger has access to it, and code outside the class has access to it. Private and public mean what the English language words mean. Private means keep it to yourself. Public means everybody gets to use it. With inheritance, we'll introduce a new access mode called protected. Protected means this class and child classes have access to the element. When class enemy declares something to be protected, they're saying I have access to it, plus I want to share it with child classes like tiger and vampire and drone. Protected says keep it in the family. I can have it and my child classes have access to it. Protected is much closer to private than it is to public. So I boxed out the class enemy here. And I've declared the variables slightly different. Each variable in enemy I've declared slightly different. It's not that I'm saying you should declare your variables this way. I'm wanting to do them differently to show you the differences between the access mode. The variable x position here, if you look closely, has been declared private. This means only the class enemy has direct access to x position. Everything in that box has access to x position, but anything outside that box does not have direct access to the variable x position. The arrow points to where that access is used to change the variable. If you look closely down here in the constructor function, I'm saying this object's x position should be set to 20. And I'm in the same class enemy, so of course I have access to my private variable. The variable x position has been declared private. If you look closely at the class tiger, tiger extends enemy and inherits that x position. When I build a tiger object, I clearly will inherit an x position variable. However, because it is private, tiger does not have permission to access x position and is not able to assign a new value to it. If enemy has a setter method, it could be called to change x position. Tiger could call parent : set x position. Even though it's private, tiger still inherits x position, but what I can't do is directly change it. That's why I drew it in red down below. This is something that is not allowed. Tiger inherits an x position variable and has an x position variable, but since it was declared private up above, tiger cannot directly access or change the value of x position. That's what private means. Enemy is saying only enemy can change x position. It does not want tiger to be able to directly change x position. Since the variable x position has been declared private, the class tiger extends enemy and inherits x position. But because it is private, tiger objects do not have permission to access x position and cannot directly assign a new value. If enemy has a setter method, it could be changed. We could call tiger object set x position if there was a set method for x position. A set method guarantees good values for the private x position variable. Once again, I'm showing you things you cannot do in red. I cannot take this tiger object that I built and use it to set the x position variable to 30. It's not that there isn't an x position variable, it's that because it is declared private, I do not get that direct access to it. You getting the point? If you declare something to be private, it's only good in that one method. The code in the child class can't directly access that variable. The objects can't directly access that variable. That's what private means. Keep it to myself. Only I get to change this variable. The variable Y position has been declared public. That means class enemy, Tiger, and all classes, all code have access to the Y position variable. Public means everybody gets access. The red boxes indicate the code that has direct access to the variable Y position. The arrows are where the access is used to change the variable. You'll notice everybody has a box around it because everybody has access to a public variable. Notice in class enemy, I'm changing the Y position variable. That's perfectly legitimate. This object's Y position should be set to 40. That's what I'm doing in the class enemy. It's a public variable. Of course I can change it in class enemy. But now go down to the class Tiger and it says this object's Y position equals 10. Y position isn't declared in Tiger. Y position is declared in enemy, but it's public in enemy. So Tiger has full access to that variable. No problem. Everyone has access to public variables. Let's go completely outside the class. Outside the class enemy, outside the class Tiger. This is a program that's using the Tiger class to build Tiger objects. Notice how a Tiger object can set Y position equal to 100. Well, how is that possible? Well, it's possible because of the public access of Y position. When it's declared public, the class enemy is saying everybody can change the Y position variable. Public means full access. This is the problem with declaring public variables. I'm showing you public Y position because you can do it this way. Doesn't mean you should do it this way. Any changes to the variable Y positions means you may have to change everywhere the variables is used. When you change private variables, you'll probably have to rewrite class enemy. But if you change public variables, you'll have to rewrite every piece of code that uses that public variable. Plus public means there's no way to prevent garbage in, garbage out. Here's the problem with public. What if I wanted to set Tiger object's Y position variable to negative 487,265? Well, that's a completely bogus Y position value. But as a public variable, there's no way to stop it. When you declare things to public, when you change those public variables, you better go check all the code that modifies that public variable. And that might create a problem. If there's hundreds and hundreds of places where you're modifying or changing that variable, that's hundreds and hundreds of places in the code you might have to go change or at least check. This is an example where I'm declaring 3 different variables using 3 different access modes. Doesn't mean I want you to declare them with 3 different access modes. And it especially doesn't mean I want you to declare things public. The only reason I declared something public in this class is to show you this example. If I was writing this code, I'd probably make Y position private. Now let's look at the third and the new access mode, protected. Over here with the red underline, you can see that the variable health has been declared protected. Class enemy and any child class, including Tiger, will have direct access to health. The red box indicates the code with direct access to the variable health. Anybody in this red box, enemy and Tiger, which extends enemy, will have direct access to health. Notice what isn't in the red box. Outside the class where I'm creating Tiger objects, we don't have access to protected variables there. The arrows point to where the access is used to change the variable. Inside class enemy, of course, I can change this object's health variable to 100. I'm in class enemy, I can change its variable. But now I can also change it outside the class enemy. Class Tiger extends enemy. Tiger is a child of enemy. Therefore, in Tiger, I can say change this object's health variable to 90. This is legal because Tiger is a child of enemy. And enemy has declared this to be protected, allowing access to the child classes. In both situations, I have access to protected. Protected gives me access into a limited number of child classes. Since the variable health has been declared protected and class tiger extends enemy and inherits health, there's going to be a health variable inside a tiger object. Up here on the right side where I create this tiger object, of course it's going to have a health variable. But because it is protected, tiger objects do not have permission to access health and cannot directly assign a new value. If you look closely, I did it in red and underlined it in red. If you look closely here, this is something you cannot do. Tiger object cannot change the health variable directly because it's declared protected. Protected means my child class can do it, but objects created from tiger will not be allowed to directly change that health variable. Protected is much closer to private than public. You can change protected variables. You're going to have to change the parent code, and you're going to have to go check and change the child classes. Are you seeing that? If I make a major change to this variable health, let's say I change the name of the variable health. Well, I'm going to have to change all the code that accessed the health variable inside class enemy. But since it's protected, I'm going to have to go to tiger and drone and vampire and any other child class. And if they mess with the health variable and I change the name of the health variable, I'm going to have to change that code. But what I won't have to change is any code outside the class that is using enemy objects. I'd much rather use protected than public. If I want to allow access to a few child classes, declare a variable to be protected. The child classes can use it, but you don't open up this big wide door allowing everybody access to that variable. Let's go back and look at PHP 4 for a second. Remember, PHP 4 was an object-oriented programming language, but in PHP 5 they made a bunch of changes and made it better, much more object-oriented in PHP 4. So there's a huge difference on the way you declare and access variables between PHP 4 and PHP 5. The variable health has been changed to what's called var access. If you're looking at some PHP 4 code, you might see a var here instead of private or public. Var access makes it public. Var and public are the same thing. Prior to PHP 5, var was the only way to declare variables, and everything was public. There's a lot of code out there that uses the var keyword instead of public. Treat it as public. Var means public, public means var. In this case, with the tiger object created outside the class, if you have a var in front of the variable, it makes this line of code good. Follow this arrow up to here. This was a dynamically allocated piece. If there was a var in front of the health variable, tiger object could change it because var means public. However, if you are using PHP 5 or above, make sure that you use private, public, and protected. Do not use var. If you see var being used in some code that you're handed, some code that has already been written, don't panic. Just remember var should be treated as public. Make sense? There's no difference between the axis of Y position, which is public, and health, which is var. And PHP is backwards compatible. You can still use the var. Even after PHP 5 came out, my host did not upgrade to PHP 5. So for a long time I was still using var because every time I uploaded to my host, I had to be PHP 4 compatible. But now that everybody that I know of has upgraded to 5, I've stopped using var. With the slight caveat that there are always exceptions to any rule, this is what I want you to do. Declare your variables private. Just make them all private. Declare your methods public. When doing inheritance, go ahead and use protected to allow direct access to the child classes and the subclasses. Avoid using var mode when you code using PHP 5 or above, but treat it as public if you see it in some existing code that has already been written. I will use protected once in a while. In the case of class enemy, a lot of times tiger, drone thing, I don't want to have to call set methods. By the way, Let's get back to set and get methods. I've talked about those before, but it's important to bring them up now. When you declare your variables private, it doesn't mean nobody has access to them. If you write set and get methods for your private variables, you have access to them. And all protected does is it means you don't have to bother using set and get methods to get access to private variables in the child class. Let's trace this code and see how it works and see where and how we can change variables depending on their access mode. I'm going to build a new tiger object out of the class tiger, and you can see I've visualized what that object's going to look like in computer memory. Follow the line here. This line of code here we'll call the tiger constructor and execute and construct the tiger object. Now here's something new that we have to look at closely. The parent : command says to run the parent constructor. You may also use parent : to run other parent methods. It simply says I want to go up to my parent class and run something. Again, this is a PHP 5 or greater thing. If you're running PHP 4, this won't work. Follow the line. See this red underline here? It says go up here and run my parent constructor. Before I do my tiger constructor, execute my parent constructor. Watch where the code goes to next. It goes and runs the parent constructor. What does the parent constructor do? It sets the default values for the properties for the variables of the parent class. The enemy constructor is going to set these global variables to certain values. This object's X position should be set to 20 and it shows up in the object. This object's Y position variable should be set to 40 and it shows up in the object. And this object's health variable should be set to 100, and the parent constructor initializes all the variables declared in the parent class. That's what it should do. When this constructor is done, it should return back to the tiger constructor. And it returns back to the tiger constructor. After returning from the parent, the tiger constructor can change the values for its variables or properties. If it wants to, it doesn't have to, but if it wants to give its own values, it can. And each child class can set their own unique values. You can see the tiger constructor has said, no. For this object, the tiger wants the Y position to be 10, and a 10 shows up or changes to the Y position. And the tiger object has decided that the health variable should be 90, not 100. And if you follow the little line here, health got changed to 90. The parent class set default health to 100. But the tiger overrode it and said, no, I want the health to set to 90. That's what you do. The child class constructor can decide what it wants in its variables. Notice what tiger couldn't do. Tiger did not change X position. Either it didn't want to, or because it was private, it wasn't allowed to change it. Once the tiger constructor completes its code, it should make its way back to the code after the call to the tiger constructor. We come back here after the tiger constructor. I only did this to demonstrate how an object can change a public variable. I prefer if you do not declare public. But since Y position was declared public, you can see it's public over here, I can, if I so choose to, take the tiger object, go inside of it, change the Y position to 100. Y positions changed 3 times. Enemy set it to 40, tiger set it to 10, and then the code that created the tiger object changed it to 100. That's the problem with public. Everybody can change it. When you're looking to see when it got changed, you have to look everywhere. This also shows when you're outside the class, you've got to use a tiger object to do it. Notice here how I said tiger object Y position equals 100 versus saying this dot Y position equal 10. I use $this inside the class. Inside the tiger object, I say this object's Y position equals 10. But outside the class, I have to use a tiger object reference variable. Remember, I could build 5, 10, 20 tiger objects. If I want to change a specific tiger object's Y position, I have to use the tiger object variable to do it. All right, so this wraps up our little lecture on inheritance here. Enjoy the rest of the lessons. I'll see you on the next one.